Hello everybody and welcome back to another fun-filled higher maths lesson. Today it is our first real piece of higher maths work. The first two lessons have been revision from National 5. I hope you're all excited for this. We are going to calculate the gradient of a line but in a different way. That's right, we are not just going to use the standard gradient formula that we did yesterday. We're actually going to introduce a brand new way of calculating the gradient. Now, some people don't like it when we give you more than one way of doing the same thing, but it's actually a good thing. So, strap yourself in and get ready for some proper hard maths. Okay, to begin with, let's go backwards and revisit something that you already know. The gradient of a line. How do we calculate the gradient of a line? Well, you know the gradient formula, but before that, we recapped it in the previous lesson as well. The gradient formula is actually the vertical divided by the horizontal. Okay, now if I just draw a triangle to show you what that actually looks like, there's the vertical and there's the horizontal. I'll fill in a wee right angle. You are going to divide the vertical by the horizontal. You are going to divide that side by that side. There is another time in maths where you divide this side and this side together, and it tells us something. If I potentially put an X there as an angle, it might start get you thinking a little bit. Anyone? Does anybody know what other area of maths we use this in? How about if I write this down? Oh yes, good old SOHCAHTOA. Trigonometry. This is when, in National 5, you would also have divided this side by this side, but it wouldn't have been called vertical and horizontal. Okay, it would have been called opposite and adjacent. When you use the tan ratio, you use the opposite side and the adjacent side. That looks like this for those that can't remember. Tan x degrees equals the opposite side divided by the adjacent side. Now, I have the same thing twice. I have the vertical side divided by the horizontal side, and that tells me what the gradient is. I have the opposite side divided by the adjacent side, and that tells you what tan x is. Both these things are the same, which allows me to make the next step. That the gradient is actually equal to tan x. At that point, some of you might have just had your mind blown. Vertical divided by the horizontal is the same thing as the opposite divided by the adjacent. Because they are the same thing, the two things that they equal must also equal each other. The gradient is tan x. If you know this angle in here, you can work out the gradient of that line. And that is another way of working out the gradient of a line. So, a little example. If I tell you that we have a grid and we have a line like this, and the angle in here is 23 degrees, I can work out what the gradient is going to be. Okay, the gradient m is going to equal tan of 23. You go to your calculator, you type in tan of 23, and it gives you an answer of 0.42. I've just worked out the gradient, and all I've been given is this angle in here. It's another way of working out gradient. Right, a little aside for a wee minute. If I draw a line like this, on top of the x-axis, it makes two angles. This one and this one. What we're interested in here is this angle. We say it's the one in the positive direction of the x-axis. This is important for something we're going to come back to later. This is the negative side of the x-axis. This is the positive side. We want this angle in here all of the time. Right. Next thing. Say we have a situation where we have our line, and this time it makes an angle of 78 degrees. We're going to work out what the gradient is. Same as before, m is going to equal tan 78, and if I use my calculator for that, it will tell me that it's 4.7. If we know the angle, we can work out the gradient. I introduced the rule as m equals tan x, because that was the two things I was working with. As always in higher maths, we like to try and make things a wee bit more complicated, and we like to change things up. The rule is actually m equals tan, and this funny wee thing in here is the Greek symbol theta. Why theta? Why not theta? Us mathematicians love the Greeks. This is the rule that we're going to use. M equals tan theta. This is a rule that you are expected to remember. Okay? Just like the gradient formula, y2 minus y1 over x2 minus x1, you're meant to know this. Right. We have worked out the gradient when we've been told the angle. Now, what happens if we're actually told the gradient? If I tell you that the gradient is 0.49, it is possible for you to go backwards and work out what this angle is going to be up here. How would you do that? Well, you're going to use the formula. What you're going to say is that tan theta equals, not m, but 0.49. And how could you get from that position to working out what theta is? Again, this is going to go back into your brain of National 5 maths. How do you get from this position to that position? What was that up the back? That's right, you've got to do the opposite of tan. And the opposite of tan is inverse tan. So I go to my calculator. You need a scientific calculator. I'm going to do the inverse tan of 0.49, and it tells me that the answer is 26.1 degrees. Which means that when I have a gradient of 0.49, it means that it makes an angle of 26.1 with the positive direction of the x-axis. Okay, so far we've focused on positive gradient lines, but what happens if we have a negative gradient? So we've got this angle, this line coming down here. I'm going to be a little bit tricky. I'm going to tell you what this angle is in here. Now, not that long ago I told you that what we actually want to know is the angle that it makes with the positive direction of the x-axis. So if I tell you that that one's 50, you need to do something first to work out this big angle in here. We're going back to angle facts, we're going back to first year. We have a straight line. These two angles will add to make 180, so this one must be 130. Once I've got that angle, then I can work out the gradient of this line. M equals tan theta. M equals tan of 130. Type that into the calculator. It tells you that it's minus 1.2. I'll show you how that works in reverse. So So now I'm going to tell you the gradient of the line, and we're going to try and work out the angle. This bit is the hardest part of the whole lesson. It relies on us remembering our cast diagram from National 5, something that you would have used when solving a trig equation. Let me just talk you through it. M equals tan theta. We are going to forget about the fact that it's a negative. The cast diagram will take care of that. We are going to do the inverse tan of 0.3, positive 0.3. The cast diagram will take care of the negative aspect. That tells me it's 16.7. Okay, now I go to my cast diagram. Because we're dealing with a right angled triangle here, the angles won't be bigger than 180. So the bottom of the cast diagram can go. Are you in this quadrant or are you in that quadrant? Well, this one is when everything's positive. It's not positive, it's negative. So I'm going to be in this quadrant. I'm going to draw 16.7, chop it off, and measure round. To get this big angle in here, well, it would be 180 if we hit this line here, but it's 16.7 short of it. So 180 take away 16.7, and that's going to come in at 163.7 degrees. Now that is the hardest part of it. If you're being given a negative gradient and you're being asked to work out the angle that it makes with the positive direction of the x-axis, you have to forget about the fact it's a negative gradient, do inverse tan of the positive number, and then you're going to use the cast diagram. You're going to take that answer away from 180 to give you the correct answer. Okay, I've done some work. Now it's time for you to do some work. So here is today's sheet. Questions 1, 2, 3 and 4. I want you to tell me the gradient of those lines. I'll zoom in so you've got a good idea of the angles. So question 1 is 42 degrees. Question 2 is 78 degrees. Question 3, downward sloping line, watch yourself on that one. 70 degrees on the left hand side. Question 4, downward sloping line, 40 degrees on the left hand side. Okay, then you're going to be asked to figure out what angle the lines make with the positive direction of the x-axis. Camera malfunction. So we've got a 0.45 gradient, a 3.2 gradient, a negative 0.9 gradient, and a negative 4.2 gradient. Remember, at this point you should now pause, you should try the questions, and then I'm going to go over the answers just in a little minute. Okay, so for question number 1, we are going to use, what is the gradient of these lines? We are going to use m equals tan theta, and m will equal tan of 42. And if you check that in the calculator, tan of 42 works out to be 0.9. Job done. On to the next one. M equals tan theta. The angle is 78. So tan is 78. Check that on the calculator. 4.7. 3 and 4. Downward sloping lines. Try to be a little bit tricky here. I've given you the wrong angle. I've given you the one on the negative side. You want this angle in here. They should add to make 180. So that's 110. So you're going to go m equals tan theta, m equals tan of 110, So m equals, type that in the calculator, minus 2.75. Question 4, same idea. This angle's 40. You need to get this big angle here, which will be 140, because they had to make 180, remember. M equals tan theta. M equals tan of 140. So m equals, check it on the calculator, minus 0.84. And that's those 4. When you've been given the angle, working out the gradient. Other way around, if you're told the gradient and you've been asked to work out the angle, so m equals 0.45. So what I would say here, again we can write out the formula. M equals tan theta. This time you're being told, I'm just going to swap these two round. I'm just going to go tan theta is going to equal 0.45. And then you're going to inverse tan 0.45, and that will tell me, if I check that on the calculator, the answer is 24.2. On question 6, you're told the gradient of 3.2. We're going to follow the same pattern as this. You're going to say, okay, so tan theta, that's going to equal my gradient, which is 3.2. Now I'm going to inverse tan. Check that on the calculator, 72.6. Right, the last two, the trickiest ones. You've been given the gradient of a negative line, sloping down the way. Remember what we did here. We're going to use the cast diagram, so we're going to forget about the fact that you actually have a negative gradient, and we're going to use the cast diagram to sort that out for us just in a little minute. So that means you're going to have to do, with a bit more space, question 7, we're going to inverse tan 0.9. Notice I haven't put theta equals, because this isn't actually going to be a final answer. So if I do that, I'm going to get 42.0. Well, just 42 is my answer. Now, I need to use my cast diagram. I'm not using the bottom half of it. Tan is negative. We've got a negative thing here happening. Negative 0.9. So I'm going to go over in the S quadrant. 42 degrees in. Draw my line. Measure round from there to there. That would be 180, but I'm 42 degrees short. So theta will equal 180 take away 42, which is going to give me 138 degrees. Same for question number 8. Question number 8, the gradient was minus 4.2. So we're going to forget about the fact that it's a negative. I'm going to inverse tan 4.2. I just need to double check that on the calculator. I think that's 76.6. Okay, and now I'm going to use the cast diagram. I'm not going to use the bottom bit, because remember, this bit deals with angles which are bigger than 180. We have a right angled triangle. The angle can't be bigger than 180. Your angle is going to be in here because we know it's going to be the negative tan. So I'm going to come round. I'm going to draw 76.6 up there. Now, if you're a bit rusty on the cast diagram, do not worry. We're going to have a trigonometry topic coming up quite soon where I'll recap everything you need to know about the cast diagram. Theta will equal 180 take away 76.6, which is 103.4. Okay people, that is the end of m equals tan theta. Takeaways from this, you need to remember the formula m equals tan theta. That's a given. And now you have a second way of working out the gradient of a line. We would only ever use this when we're told the angle, or we can work out the angle. Notice it's got nothing to do with coordinate points.